So in this section, we're going to talk about thiols. Thiols are alcohols, but in a normal alcohol, we have oxygen, but in a thiol, instead of oxygen, we have sulfur. Remember, oxygen and sulfur, they are in the same group. Right below oxygen, we have sulfur. Okay, in the periodic table, so you have sulfur, and right below oxygen, you have sulfur. Okay, so oxygen can form alcohol with hydrogen, and sulfur, we call it as thiol. When the hydrogen combined to sulfur, that's a thiol. Okay, so this is a thiol, CH3CH2SH. In the presence of a mercuric acid, if you have two thiols, you can see that the thiol can capture mercury. Thiols used to be called mercaptans because they capture mercury. Okay, here's how we name thiols. So this one is called ethane thiol because if there are two carbons, that's an ethane group, ethane thiol. And this one would be 1-propane thiol because to represent where the sulfur is, or the thiol group, 1-propane thiol. And this one would be there are 1, 2, 3, 4 carbons on the main chain, and on the 1, 2, 3rd carbon there is a methyl group. So we can name it as 3-methyl 1-butane thiol. And then this one has an alcohol group and also thiol. So this one would be 2-mercaptoethanol. Notice here, alcohol, OH, gets more priority. So 1, 2. So the second carbon carries a thiol group. So that is represented as mercapto. And it's in the second carbon, 2-mercaptoethanol. Okay. Thiols, pK is about 10, are stronger acids than alcohols. Alcohols, pKa is about 15. Thiols, pK is about 10. And thiols are stronger acids because it has a lower pKa compared to pKa of alcohol. Thiols have lower boiling points than alcohols. Ethane thiol about 37 degrees and ethanol is about 78 degrees Celsius. Thiols are good nucleophiles in a protic solvent. Protic means solvent carries protons in it. Okay, so this is methyl sulfide, act as a nucleophile, and this is ethyl bromide. So you can have a substitution similar to SN2 fashion. So sulfur attacks the primary carbon and bromide leaves in the presence of methanol. It's a protic solvent and it's going to generate methyl group coming from the sulfur, and then with these two ethyl group attached to sulfur. Okay, thiolate ions are better nucleophiles than alkoxide ions in a protic solvent. Alkoxide meaning this group, alkyl group and O minus. So that is the alkoxide ion. Okay, so thiols are better nucleophiles compared to alkoxide ions. The product is a sulfur analog of an ether, and we can call it as a thioether or a disulfide. Thioethers are also nucleophiles. So this is a thioether, dimethyl sulfide. Can act as a nucleophile. So you have methyl iodide. So sulfur carrying 2 lone pairs can act as a nucleophile, goes and attack the methyl group and leaves the iodide. So this one forms trimethyl sulfonium iodide, a sulfonium salt. And this sulfonium salt that we generate in the last slide is an alkylating agent. Meaning, if you want to alkylate a hydroxyl group, you can use a sulfonium salt. Because sulfur is carrying a positive charge, so the hydroxide acting as a nucleophile can go and attack the methyl group and then break the sulfur carbon bond and releasing the positive charge, so the sulfur will become neutral, and then hydroxide will be methylated because it's a alkyl group. We call it as alkylating agent. And this is how a chemist would do a methylation. Like you have the nucleophile and then you have the methyl iodide. Nucleophile attacks the carbon and leaves iodide. So methyl plus the nucleophile. Okay, and this is a methylation by a cell. So cell is doing something similar to what we have just talked about. So in a cell you have a nucleophile, and then you have, this is a sulfur containing group. Sulfur has a methyl group on it, so the nucleophile can come and attack carbon, and then the sulfur having positively charged, carbon sulfur bond breaks, and then the sulfur will become neutral again without any charge, and it's going to form nucleophile with methyl. Okay, and this is S-adenosyl methionine, abbreviated as SAM, adomet, and then this is S-adenosyl homocysteine. Okay, and this is the leaving group, and this process takes place in the cell. Another example, no adrenaline to adrenaline, and here again no epinephrine or no adrenaline has a nitrogen with a lone pair, and now this is going to be the nucleophile, goes and attack the carbon, methylated epinephrine, and now become adrenaline, and this whole thing is the leaving group, so sulfur containing group. Okay, so those are two examples in thiol chemistry, sulfur chemistry, what's happening in the cells. And this concludes our chapter 10. And in chapter 10 we learn about group 2 compounds, and these are the group 1 compounds. We learned more about it in organic chemistry 1. Alkenes, alkynes, dienes, these are nucleophiles, undergo electrophilic addition reactions. And in the group 2 we talk about these functional groups and their chemistry. And they undergo nucleophilic substitution and or elimination reactions. Okay, and then in the next few chapters we're going to be learning about group 3 and group 4. So this concludes our chapter 10.